Welcome back. We are looking at differentiation under calculus, and we have a question from the Examinations Council of Zambia 2019 GCE. The question reads, find the equation of the tangent to the curve y is equal to, in brackets, 2x plus 3 all raised to the index 3 at the point where x is equal to -1. Solutions. You and I know that when we are given the equation of the curve y, and when we differentiate the equation of the curve y, what we get is dy dx. So when we differentiate y, what we get is dy dx. Now, this dy dx is called the gradient. It is also called the gradient function. It is also known as the derivative, also called the derived function. Okay, so when we have the equation of the curve y and we differentiate, what we get, dy dx, is the gradient or the gradient function or the derivative or the derived function. Now, getting back to our question, find the equation of the tangent to the curve y is equal to this at the point where x is equal to 1. Now, we know that the equation of a straight line should look like y minus y1 is equal to mx minus x1. And we know that where we have x1 and y1 is the coordinate where this function is passing through. So from that coordinate, which should be in the form x comma y, we are only given the x coordinate, which is -1. We are not given the y coordinate, which we are supposed to come and put here. We are only given the x coordinate, which we are supposed to come and substitute for x1. So, if we want, we can start by getting the y coordinate. Now, the way we get the y coordinate, we need to substitute the x coordinate into the given function. So, substituting our x coordinate into our given function, we have y is equal to 2x plus 3 all to the index 3. Okay. So evaluating that one, we have 2 by -1, we get -2 plus 3 index 3. We know -2 plus 3 gives us 1. So we have 1 index 3, which gives our y as 1. Okay, so Using our x coordinate, we have also gotten our y coordinate, and our y coordinate is 1. So we have the coordinate where this curve passed through. So this curve passed through the point -1, 1. Okay, now let us move on. So this coordinate -1, 1, we shall come and substitute it here for x1 and for y1. Now, we do not have m, which is the gradient at this point. So, we need to find the gradient of the tangent at this point. So we shall say, getting the gradient, we know that when we are given a function y, for us to use it to get the gradient, all we need to do is to differentiate. So when we differentiate, we shall get dy dx, but we know dy dx is the gradient. So we need the gradient, which we shall come and put here. So for now, the equation of the tangent looks like this. Y minus, now for y1 we shall put 1. So y minus 1 is equal to, we do not have m. So m, we shall solve for m later. For now, x minus, so for x1 we shall put minus 1. Okay, so for now, our equation of the tangent looks like this. Okay, so for now, the equation of the tangent looks like this. Now, we need to find the gradient of the tangent, which is represented by m in this formula, in this expression. So getting our m, which is the gradient, we know we need to differentiate y. So our y is this one, so we need to differentiate. We know when we differentiate, what we get is the gradient, also called the dy dx. Okay, so let us differentiate that one. What we have is y is equal to 2x plus 3 or indexed to 3. Okay, so differentiating this one, we shall apply the chain rule. We shall apply the chain rule, which says we shall multiply the index by the coefficient here. At the front here, we know the coefficient is 1, so we shall say 3 by 1, we shall get 3. Then what is in brackets will remain the way it is, and the index will reduce by 1, so it will be 2. And whatever we have there, we shall multiply by the derivative of what is inside there. So when you differentiate what is inside here, what you have, this one will give you 2, and this one will give you 0. So basically, this is a simplified version of how to use the chain rule. When you have an expression, the equation of a curve, which is indexed like this one, using the chain rule, we multiply the index by whatever you have in front here, then the index reduces by 1, and you maintain what is there inside, you maintain it. Then whatever you get, you come and multiply by the derivative of what is inside. So this is what we did, 3 by 1, 3, and the index reduces by 1, so 3 minus 1, 2, Then we maintain what we had here, we put it here. Then we multiply by the derivative of what is inside. So the derivative of what is inside here is 2. So this dot here, it is standing in for multiplication. You can see it is in the middle here. It is not down here. When it is down here, you know what it means. It means it's a full stop. But you can see it is in the middle here. It is not down here. When it is in the middle here, it means multiplication. If it is down here, it means it's a decimal. It's a decimal point. Okay. So finally, our dy dx is, we can multiply this 2 by 3, and we are going to get 6 outside. Then inside there we shall have 2x plus 3 index 2. So basically, this is the gradient function. This is the gradient function. So basically, we have differentiated this expression, and the derivative of this is this one. Now, this is the gradient function. It means we need to use this gradient function now to get the gradient at x is equal to -1. So we need now to substitute in our dy dx. We need to substitute for x. We put -1. Since our interest is to get the gradient at x is equal to -1, which we shall come and put here, here, so that we complete our equation of the tangent. We know that when you differentiate a function and you get dy dx as this, and you substitute for x, we know that the first gradient that you get is the gradient of the tangent. And what we are asked is the equation of the tangent. So, because we are asked to get the equation of the tangent, therefore we need the gradient of the tangent. And we need the coordinate where this curve is passing through. So the coordinate, initially we were just given x as -1. So we went on to find a full coordinate, and we got -1, 1. So proceeding from there, we have dy dx is equal to 6, 2. Now we need to substitute here. We need to substitute for x. We put -1, so that we get the actual gradient at x is equal to -1. So dy dx is equal to, we have a 6 outside, and 2 multiplied by -1, we have -2 plus 3, all indexed to 3. So dy dx is equal to 6, -2 plus 3 will give us 1, indexed to 3. So finally, dy dx will be equal to, now 1 index 3 will give us 1. When we multiply 1 by 6, we shall get 6. So 6 is the gradient of the tangent. The gradient of the tangent, and we are told to get the equation of the tangent to this curve, and we know that the equation of the tangent would look like this. What we are just remaining with is our m here, which is the gradient, and we know dy dx is the gradient, so where we have m, we are going to put our 6. So substituting for m, we substitute 6 for m, so that we complete our equation of the tangent. So we have y minus 1 is equal to 6. So for m, we have put our gradient, and we have x plus 1. Okay, so simplifying, we have y minus 1 is equal to 6 by x, we have 6x. 6 by 1, we have 6. Okay, so we have y is equal to 6x plus 6. Now, moving this negative 1 from the left hand side to the right hand side, we shall have plus 1. So finally, our y is equal to 6x plus 7. So basically, this is the equation of the tangent to the curve at x is equal to negative 1. So basically, whenever we are asked to get the equation of the tangent to the curve at a given point, we need first to find a gradient, which we get by differentiating, and now use the gradient in this simple formula. Thank you very much for your attention. Subscribe to my channel.